Thanks for coming for my session. So for the next 60 minutes or so, I'm going to talk to you about developing native Android applications using React Native. Now, before we get started, let me try to understand your background. How many of you are actually mobile developers? You write mobile apps. Okay, so for all those who put up your hands, how many of you are actually Android developers? Okay, and how about the rest? iPhones. And that's why you're here. Yes? So for those of you who actually put your hands up, you are Android developer, what languages, what tools do you use to write your Android apps? Android Studio? Java? And how many of you have actually tried React Native? Okay, only one. And okay, so that's good. So for the next 60 minutes, you will believe whatever I say, right? So, okay, so now my name is Wei-Meng. So I come from Singapore. So I have my own training business. It's called Developer Learning Solutions. So I basically focus on mobile development. So in particular, iOS, Android development. And in more recent years, I've also been dabbling with Python, machine learning, so on and so forth. So, but mobile is still something that gets me really excited. So, okay, so let's dive into the agenda for the next 60 minutes. So first of all, I want to get you started with React Native. So I think most of the audience here are already familiar with React. So that needs no introduction. So React Native is actually born out of React. So if you know React, you should be pretty familiar and comfortable with React Native. So I will explain to you anyway. So I will give you some motivation of why you want or you should use React Native. And hopefully, at the end of this session, for those of you who have been using Java and Android Studio, you should kiss your Java goodbye and say, okay, let's embrace JavaScript and start writing our React Native mobile apps using React Native. Hopefully. And I'll show you some really cool features of React Native called live reload and hot reload. How many of you have actually heard of these two terms? Okay, so quite a number of you. Okay. So, and I will talk about how to actually perform some of the common tasks for mobile development using React Native. So for example, if you're coming from the Xcode background, Android Studio background, and you want to move into a new development environment, I think the first question is, you always ask yourself, okay, so what's the language that I'm going to use? And how do I do this? How do I do that? So for example, how do I actually perform navigation? How do I create a tab application? How do I actually get the location of my device? How do I display a map? So on and so forth. So I'm going to answer that questions in this session, how you can actually achieve all these common functionalities using React Native. And I'm going to show you something that's really, really cool. Live updates using this thing called CodePush. Now, if you have been doing mobile development, you know the pain. So in the past, you spend a few months creating your applications, and then when you are finally done, you upload the application to AppStore or to Google Play, and then what happens next? So Apple typically takes about 2 weeks to approve your apps. All right? And then when your apps got approved, I think that's the happiest moment in your life. For those of you who have actually deployed apps before, do you agree with me? When your first app gets approved on the App Store, that is the happiest moment in your life. Don't tell your wife this. Your wife wouldn't agree. Now, what is React Native? Now, before I go to the React Native, let me just complete this. So once you have actually gotten your apps approved on the App Store, so you are so excited, your users are all using your apps, and then suddenly somebody say, there's a bug in your app. And you say, oh, okay, let me fix the app. And then you update the app, you reload that to App Store, and then Apple says, okay, we will review your app, we will take another 5 days to approve your apps. And then you say, gosh. So in the next 5 days, that's the most painful period of your life. So using CodePush, you don't have to do that. As soon as your application using React Native is actually deployed onto the user's device, you could simply make the changes, upload your changes to CodePush, and then you could actually write some logic on the application so that you can periodically check for updates, and then you can bypass AppStore when it comes to updates. But this is a little bit of a grayish area, so Apple may reject your app based on this, but most of the time, from what I heard, Apple is okay with this. So I'll show you a demo later on. So what is React Native? It's a JavaScript framework for creating native iOS and Android apps. So notice that I focus on the word native. So this is a pure native app. This is not an app that works like your Cordova or your Ionic applications, which are hybrid applications. This is a pure native app. You are a first-class citizen on the platform. So for this session, I'm going to focus on Android. For my next session, I'll talk more about iOS. So it's based on React, Facebook's JavaScript library for building UI. And your native apps are written using a mixture of the following. So JavaScript. So if you are sensitive to this word Java, then you shouldn't be here. So we're going to use this language called JavaScript together with CSS. And I think the good news is that I think most of you are also web developers. Okay, so if you're web developers, CSS is something that you eat for breakfast. So this is no big deal. And then JSX. So JSX, in my opinion, stands for JavaScript extension. So it's a combination of JavaScript together with XML. So you're going to see that later on. Now, using the combination of JavaScript, CSS, and JSX, the React Native basically translates your UI markup. So your UI markup is actually these three components. And it translates your UI markup to native UI elements so that your app runs as a native app. Sounds too good to be true. But don't worry about that. So why React Native? How many of you have requirements from your customers that says, I want your app to be able to run on multiple platforms, iPhones, Android, Windows Phone. No, forget about Windows Phone. What other platforms are there? What other mobile platforms are there? BlackBerry. Forget about BlackBerry. I think we are left with iPhone, iOS, and Android. So how many of you have this kind of requirements? If your customer says that, oh, I only want Android, I only want iPhone, they're lying to you. Tomorrow, when your app is done, they'll come back to you and say, hey, this one looks good on Android. Can I have it running on iPhone? Okay, so React Native allows you to write cross-platform apps really, really easily. Now, I think most of the folks in this conference are Microsoft users or Microsoft developers. So you guys eat C# for breakfast. So I'm sure you have heard of this thing called Xamarin. Anybody started on Xamarin projects? Okay, so how do you find Xamarin? It's all right. It's all right? Yeah. Okay, how about the rest? Those who put up your hands? Okay, never mind, you can tell me privately. Now, so when I was starting out on React Native, because I've been spending a lot of time doing Objective-C, Swift programming on the iPhone side, and then I've been doing Java on the Android Studio side. So when I first started on React Native, I wanted to see how effective this is. So I started out by building the NDC Sydney application to convince myself that this is really good. So I took about 2 weeks. From downloading the JSON data, trying to repurpose the data, and then try to understand the various navigation models, what are the things you can do, what are the things you cannot do, and I was pretty impressed. So, and I wanted to be able to run my application on multiple platforms, iOS and Android. So ultimately, I think I managed to get 99% code reuse. So basically, it's write once, run everywhere. Right? Sounds familiar. So now, your apps retain the native look and feel of each platform. So your app is pure native, so that's why it looks just like a native application. And it is really useful for testing. You can use live and hot reloading. and you can instantly see the changes in your app. So for those of you who are new to this feature, later on, let me show you a demo on this. And it has got very good community support. Now, React Native is sort of like, it's open source. So the good thing about open source is that when you have a problem, you go to Stack Overflow, and that is a solution. Yes? So I always like to tell my friends, real programmers don't write code. Real programmers go to Stack Overflow, copy and paste code. Yes? But that's a little bit unfortunate because today we live in a very fast-paced world. Things are changing so fast, and most of the time you are just copying and pasting as long. But I think if you paste with understanding, I think that's okay. So whatever you need, there's a package out there that can satisfy your requirements. And as the saying goes, there's a package for that. Okay? Now, and I mentioned earlier on, there's this thing called CodePush that allows you to have dynamic app updates. So that is something that is really, really cool. So I'll show a demo to you later on. Now, how to install React Native? It basically uses Node.js and NPM. So you could simply follow the instructions on Facebook's React Native page, install this, and install this tool called Watchman. So Watchman will basically monitor and observe your files, and then when there are changes, when you make changes to your code, it will automatically refresh your emulators or your real device. So I'll show you later on. Now, the best way to look at a new platform is through the traditional Hello World. So let's show you a demo. So I have the Android emulator already up and running. So I want to create a new application. So I'm going to call my application Hello NDC. So I simply do a React Native init Hello NDC, and I can specify the version of React Native that I want to use. So I got some problems with the latest version, so I'm going to fall back onto the slightly earlier version, 0.44. The good news of React Native is that it is still in its very, very early stage. Quick question, when was React Native released to the developers community? Anybody? 2015, March. So it's about 2.5 years old. So the good news is that when you go for interview, your employer cannot ask you, do you have 10 years of experience on React Native? Bullshit, right? So I'm going to create a Hello World application. So press enter, and then it will go ahead and create a bunch of files. If you're familiar with Node.js, you know that you have a Node modules created with all the packages. I'll show you in a moment. So this guy is working very hard. And what happens here is that this is the folder. This is the folder that I have, and Hello NDC. And I have a Node modules folder that contains all the modules that your application is going to use. And it's just going to create a few more folders and a few more files. OK, I think we are done. Now, so this is the basic setup of your project. So first thing first, you have a folder called Android. So this is where your Android Studio project is located. So once you have created your React Native project, you could actually use Android Studio, open up this folder, and this is an Android Studio project, and you can deploy as per normal. You have another folder called iOS, and this is where your Xcode project is located. So if I double click on this, I will see Xcode. And then I have two very important files, index.ios.js. So this is the entry point of your iOS application. And this is the entry point for my Android application. So if I double click on this guy, and if you are familiar with React, this is nothing new. So I import my React and component from the React framework, and I import the following from my React Native framework as well. And I have a component, and this is my UI. So I have a render method that renders my UI, my screen. And in this case here, you look at this guy. So this is your, and this looks like your HTML, right? Looks like HTML. Or for those of you who are coming from the Xamarin, it looks like your XAML. So in this simple example, you have very similar, this looks very similar to your HTML. Now, in fact, this whole block here is called JSX. JSX. So it's a combination of your XML plus your JavaScript. Later on, I'm going to show you some example of JavaScript statement within this block of code. Now, so how does this look like when I run this on the Android simulator? So let me just go back to my command line. Let me cd into hello NDC, and let me just run this. So to run this, I have two choices. I can either open up my Android Studio project, deploy through there, or I can run it through the CLI. I can do a React Native run Android. So I'm going to press enter. And it is going to start something called the Packager Manager. So this runs behind the scene. And so let this run for a while. This guy is very busy compiling my code and trying to deploy this onto the emulator here. So, OK. OK, so far so good. Sometimes the problem with open source is that if everything works, it's really, really beautiful. But then if something doesn't work, you will pull your hair out. You know? So that's why I observed that a lot of developers have very short hair. So OK, so it's installing onto my emulator now. Cool. OK. There you go. So if I were to compare this with this guy, can you see whatever you have here is here? Make sense? And you have you have your style sheet that defines your look and feel. So I don't think I need to explain to you what's a style sheet. So now, using your traditional tools like Android Studio, so you make changes on your code. So let's say now I want to change this to something else. Welcome to React Native. Welcome to my session. What would you do? You're going to save this, and then you go to your Android Studio, redeploy, right? So React Native, you don't have to do that. You just need to save your code. And there you go. OK? Now, the reason why it does this is because previously I've already done what we call live reload. So if I were to select this enable live reload, so whatever things I change here, the moment I do a save, it will automatically update my application. Try to do that on Android Studio. You cannot do that easily. OK? Sure.
When you started the application, did you have to point to the emulator? Or do you have to tell them where it is?
No. You just need to start up your emulator. That's it. If there's only one and only one emulator, it will automatically deploy to the only one emulator that's running, or device. So if you shut down your emulator, you have only your device connected, it will deploy to your device automatically. OK? OK, now, or you could, if you were to deploy this on the real device, how do you actually bring up this menu? Oops. Sorry. So if you are running this on a real device, how do you actually bring up this dev menu? So you have to, when you deploy this application onto your real device, now first of all, by default, it will not work. When you deploy this onto a real device, it will not work. You need to configure some settings. But before we talk about that, let me show you how to bring up this menu. So once you deploy your application onto your device, you simply take your device and shake it. You shake it, this device will pop up. So for every new application that you deploy on the device, you need to shake your phone. So when I first started on this, I was deploying this on my real device, I was shaking my phone. And then my wife saw me doing that, and she thought I got a fit. And she said, what happened to you? Why are you always shaking your phone? So, now, okay, so this is your hello world. Now, look at this. Look at this guy. So this is what we call the packager manager. So the packager manager is always running behind the scene. So whenever you reload or you make some changes to your, for example, let me just make some changes. Welcome to my session. And I save this. The packager manager will actually work behind the scene, recompile, and send the updated UI back to my application. So the packager manager is running as an independent web server, listening at port 8081. So it's always listening behind the scene. Now, when you deploy this onto real devices, you need to do this. You need to go to dev settings. You need to go to set your debug server. And you need to key in the IP address of your machine followed by 8081. Okay? If not, you will see the very famous red colored screen. You go to Stack Overflow, you see all the questions talking about this. Now, so this is my hello world. So let me just run through this. If you want the slides, I will put it up on my website, or if you email me, I'll send you the slides so that you can actually look at this, so you don't have to worry about copying this. So you start your AVD manager, you start the emulator instance, and then in the project folder, just do a React Native run Android, and then you automatically run. So, and then for real device, connect your real device to your computer, and then run Android, and you shake your device to bring up the dev menu and configure your server host. So this is what it looks like. So dev settings, debug server host, enter your IP address, and then that's it. And then reload, and your application will now be running on your Android device. So this is how it works behind the scene. So React Native basically takes your code, and then it bridges your code to the respective platform. So at this moment, you have support for iOS, support for Android, but what I recently read was that some other companies have actually agreed to support React Native. One company in particular, Microsoft, it's talking to Facebook to support their applications, not Windows Phone, but I think maybe Universal Windows Platform or something like that. And another company, Samsung. Samsung is also talking to Facebook to use Facebook to support their TVs, I believe. How many of you actually use Samsung TVs? Okay. And you have a camera, on your TV? Okay, never mind. Now, you read about all the security flaws with. Okay. So when you go back tonight, it's good for you to buy an LG TV. No, I'm just joking. So for React Native, in this case, they take the view element here. They will basically convert this into UI view for iOS, and then you will convert this into the view element for Android. So this is how it works behind the scene. Very similar in concept to Xamarin, for those of you who are familiar with Xamarin. Now, React Native brings us closer to this phrase that I'm sure you heard of this in 1995, unless you were not born in 1995. Write once, run everywhere, right? But I think if you are a developer, you are very familiar with this: write once, debug everywhere. Correct? Where were you in 1995? 3 years old. Okay. Debugging. And you saw this fella, right? Java Spring? Duke, the Java Duke. The silly mascot that keeps on jumping around. You know, that was in 1995 when they released this thing called Java Applets. Suddenly, you can make your web pages bounce. So I was a third-year student finishing my studies, and we heard of this thing called Java Applets. We were so excited. So we said, hey, finally you can make your web pages bounce. And then me and my few friends, we started a company. And we went around telling companies that, hey, we can now make your web pages bounce. And then the companies just look at us. And then my company didn't do well, so that's why I'm here today. Okay, so now JSX, JavaScript extension. So you can combine your UI markup with JavaScript. So this is one example. I have my UI, which is XML, and then I have my code, which is JavaScript. Now, when you look at this, what's the first thing that comes into your mind? To me, the first thing that reminds me of is ASP. You know, we have a term for this, spaghetti code. It seems like we are back to square one. So we are back to the stage where we have UI plus code. But this is not that bad as spaghetti code in ASP. So now, JSX will make your life really, really easy in React Native. You don't strictly have to use JSX, but if you don't use JSX, your life would be a little bit miserable. So you look at this. So I have a view element, and within my view element, I have a touchable opacity, and I have a button. So basically, this means that I want to have a button that is touchable. Now, if I don't write it this way, using JSX, my code is going to look like this. Purely JavaScript. Okay, so it really depends on you. Depending on your threshold for pain. So now React packager. That's the one that I told you just now. So the React packager basically converts the source code of your app, and it basically what it does is that it transpiles your code from JSX to ECMAScript. It converts your code from ECMAScript 2016, also known as ES7, and ECMAScript 2015, also known as ES6 to ES5. Now, all those Java developers are crazy people with all the different namings. You know, ECMAScript 2016, and then they rename it as ES7. They can't seem to make up their mind. So basically, that's the use of the React Packaging Manager. And it serves your destination code at the following URL. Now, so this is what happens behind the scene. So earlier on, when I was running my Hello NDC application, the React Packaging Manager is actually serving my code at this URL. And if you were to use a browser, point to this URL, you will actually see one whole bunch of JavaScript. And this is the one that is being sent to your application, and your application, your Android Studio application will take this code and build a UI. Okay, let's move on. Now, for laying out elements, so React Native uses Flexbox for laying out components. Those of you who are using Android Studio, you typically lay out your UI using things like linear layout, relative layout, and then lately they have this thing called constraint layout. Sounds familiar? Yes? No? And this is, do you know who is this guy?
Jackie Chan.
Jackie Chan? I know you guys love him. I don't. But anyway. Is this recorded? Can we just cut out that portion? Now, so Flexbox basically offers the following properties to help you lay out your views. So things like flex direction, justify content, align items. So let me just show you a very quick basic tutorial on Flexbox, and then we can get moving. So basics of Flexbox. So I have a view, and within my view, I have another view. And my first view, my container view, has got this container style. So it has got justify content, center, align items, center, and then it has got background color of this, and then within my container view, I have another view, width 80, height 80, and the background color is actually blue. So imagine, how would the UI look like? Make a guess. Okay, just imagine this in your head. Do you get what I have? So because I have a view container, I have another view. So 80, 80, center, center. So that's the basics of Flexbox. Now, flex direction. One more example. So imagine again in your head. So I have the container, and now instead of having one children, I have two more children. So I have two more, 80, 80, and then different blue. How does it look like now? Stack. This way or this way? On top of each other? Vertical? By default, all items in the container are arranged vertically. You get this. Okay? So, one more. So this time around, same setup, but I want to change my flex direction. I want to set it to row. So this time around, it looks this way. Okay? Sizing, I can use this flex attribute. So I have flex colon 1, flex colon 1, flex colon 1. And my direction is row. Now, tell me, how is this going to look like before I show you the answer? For the tree, it will. So it will distribute the size equally because each one says flex 1. So think of this as ratio. Okay? So by specifying flex 1, each view will take all the available space. Okay? Because there are 3 of them, they have to share. And so in this case, flex colon 1 will cause the width attribute to be ignored. Even though you have a width attribute up there, it is ignored. One more. So this time around, I change it to column. I will display it in column form. Maximum width. How is this going to look like? So now I'm switching back to flex direction row. And for the first view, I want to have the maximum width 90. And then the rest doesn't have the max width attribute. So it's going to look like this. So basically, it says that the first view, max width 90. Okay? And you can go no more than that. And the rest of the width, you guys go and split it up among yourself. Okay? One more time. Flex 1, 2, 3. So I think now it's easier to. Yeah,
6 spaces and last one will take 3.
Yeah. So in the ratio 1, 2, 3, right? So in this case, you get something like this. Okay. So straightforward. How many of you have actually done iOS programming? Xcode. Okay. Xcode uses auto layout, right? Which is a pain in the back. Next thing, justifying content. So now I'm switching the flex direction back to column. Okay? And I am doing a justify content flex start. So can you imagine how it's going to look like now? So all the items would be aligned to the top. Flex start. Okay? And so you specify flex 1 for the view containing all the 3 other views so that it can occupy the entire column. So the first this view itself actually occupies the entire column. And the justify content attribute indicates how its children should be justified. So flex start means position it at the beginning of the container. And there's a huge confusion between this attribute called justify content and align items. So let me just set the record straight. So if the flex direction is set to column, then justify content affects the vertical alignment and vice versa. Okay, so just for your information, in case you come back to this slide again, you want to clarify the difference between justify content and align items. Flex n. So position at the bottom. Space around. So I can have this thing called space around. And in this case, it will distribute the spaces so that each item would have the same amount of space between them. I can also specify space between. And so this would specify that all these items are distributed by the same space in between them. Okay, so far so good. Next thing, we want to discuss two important concepts. Now, again, if you're familiar with React, this is no stranger to you, and that is state and prop. So let me just define to you what is state and what is prop by showing you a very simple demo. So what are, first of all, props? Props are set by the parent, and their values are fixed throughout the lifetime of a component. So props are really properties of a component. So now, first of all, what is a component? So in React Native, everything is a component. So for example, you create your own custom button. Your button is a component. And so props are basically the properties of that button. So when you try to add that button to your UI, whatever things you pass in as attributes, they are known as your props, your properties. Next thing, states are used to trigger re-rendering of your app's UI. So they are generally initialized in the constructor of the component, and you call the set state when you want to change the state and re-render your UI. Now, I think the state is basically the most difficult concept for people who are moving from native development over to React Native, because that requires a little bit of different types of thinking. So let me show you a demo. So let me just put this one side and just kill this guy. Okay, let me just close off this packaging manager. Okay, so I have another example that I have written. And let me just deploy this. And when I'm deploying this, I'll show you the code. Okay, so it's called Spinner. And let me open up my Android. Okay, so I'll show you the code first, and then you tell me what my code is doing. Okay, so it's pretty simple. I have a button called my button. So my button basically draws a view with a text, and it displays a label. So essentially, this is my custom button, and my custom button is called my button. Quite a lame name, but you know. So in my main page for my application, I have the following. So I have a constructor. First of all, says that I have this dot state. So, and I said that state animating is equal to true, and button label is equal to this string called stop animating. And then in my render, I basically have the following. I have my button, and I have this thing called label. So this label is the attribute that you pass into this component called my button. And so in this case, this label would be known as the props of your component, your properties. You following me? And my button has got this label equal to the following, this.state.button label. So if you recall, my initial text for button label is stop animating. So let me see whether, okay. So by default, when it is first loaded, the spinner is loading, is spinning. And my button has got this event handler called animate. And when I click on this button, it will go to this function called animate, and I check. If the button label at this moment is equal to animate, set the label to stop animating, else set it to animate. And next thing, once I'm done, I do a set state. So in this case, initially, my UI has got the following state. My button has got the following label assigned to this state, and the activity indicator, which is a spinner, whether it is animating, is set to this particular state. So when I click on this button, it goes to animate function, and I want to change the state. The moment I call this change in, I call this function called set state, it would change the value of the states that I specify here, and it would cause the render method to be rendered again. And this time round, when I click on stop animating, it will stop animating. If I click on this, it will continue to animate. Okay? So this is the key challenge that you will encounter if you are coming from the traditional Android Studio platform, where you use functions like find view by ID. You get a reference to that, and then you change the caption of that, button.text equal button.setText, blah, blah, blah. So this is called state and props. Okay, so now that we have covered the basics, so let me talk about some of the key concerns. So before you actually take the plunge and move into React Native, you want to know, how do I do certain things? So I hope to answer your questions in the next few slides. Now, these are the built-in components in React Native. All those that has got a suffix of Android only works in Android itself. All those that has got a suffix of iOS works only on iOS. All the rest are supposedly cross-platform. So if you are developing cross-platform applications, be sure to pick the right components to make sure that it displays correctly on both platforms. So for example, you have things like image, which should work on both platforms. And if you, for example, if you use the date picker iOS, that unfortunately only works on iOS. But that's not the end of the boat. So I'll talk about that. What happens if the things that you need here, they are not listed in that slide? So just remember, the community support is really fantastic. Whatever you need, people have that. Now, the first thing that you probably will ask is that, oh, I want to display a list of items. So in Android, you can use the list view, and then you can, for those of you who are doing Android, you may also have fragments. So for displaying a list of items, you have two choices. You can either use a section list. So for the NDC application that I have, for viewing the agenda, I use a section list. Section list allows you to display section headers. So for each section headers, you can actually render whatever things you want, and then you can render all the individual items. You can also render your separator if you want to draw a line between items. So you use something called a section list. Okay? Now, but if you want to have a simpler way of listing items without the need for section headers, you can use something called flat list. So the flat list is what you will see in your NDC app when you go to search for speakers. So it's just a list of items. So pretty straightforward. Next thing, a lot of people are building location-based services. So you need to know your user's location. So React Native comes with the geolocation API. So it's basically very similar to the web-based geolocation API. And you only need to add in the necessary permissions to your iOS as well as Android projects. And then your application will be able to get the user's location. So this is a sample code of how it looks like. So you use the navigator.geolocation.getCurrentPosition. And then you use the navigation.geolocation.watchPosition. So this would be fired whenever a new location is obtained. So in my example here, I want to change the state of latitude and longitude so that I can update my UI to reflect the latest latitude, longitude that I have obtained. Next thing, after you have gotten your locations, you want to be able to display maps. So this is one of the most painful things that I encountered initially. So, but luckily, there's a solution. So if you want to display maps on your Android as well as iOS application, the best solution is to go to this component from Airbnb. So Airbnb has got this React Native Maps component where you can actually download, install into your application. So generally, this is how you actually use third-party components. So this is the way to survive. So you are doing a React Native application, and then you want to do something. I can't find that functionality natively. So you go to Google, you search for a React Native component. So you encounter this React Native Maps. So the first thing you do is cd into your project folder. You do a npm install React Native Maps. So basically, you download that module into your current project, and then you do a link. Link will update your Android project, your iOS project, your Xcode project, so that they have the required libraries in your project. So generally, this applies to most of the components that you will encounter. Okay, and for the React Native Maps component, it uses Apple Maps for iOS, and it uses Google Maps for Android. So for Android, you need to apply for the Maps API key, which I think most people are already familiar with. So this is how it looks like. Data storage. Now, most people use two ways to persist data. So in Android, you could use a SQLite database if you want to, or you could use, what's the way that you, what about the API that you use to store key value pairs in Android? Let me see whether you are really Android developers. What's the API that you use to store key value pairs in Android? Shared preferences, right? Did I say the wrong thing? Okay, never mind. But anyway, so in Android, we have this class called shared preferences, so which allows you to store key value pairs very easily. So the equivalent of shared preferences in React Native is async storage. So async storage allows you to store key value pairs into your storage without needing you to worry about how the underlying file system or database works. But if you want to store structured data using SQLite, there are a lot of components out there. You can use the React Native SQLite storage component. Again, install that into your project, link that with your project, and then you can have access to SQLite database. Networking. Of course, your applications want to talk to the outside world. Now, in React Native, there are a few ways to talk to the outside world. You can use the fetch API, which returns you a promise object. So you can connect to a URL, get back the response, convert this to a JSON, process the JSON file, update your UI, whatever things you want. Or for those of you who likes to use XML HTTP requests, it is also available in React Native. And WebSockets is also supported. And there are also third-party modules like Socket.io. I'm sure you have heard of this, Socket.io, that allows you to connect to your backend using sockets. Navigation. So when I was building this NDC application, I wanted a way to build a tab application, but at the same time, I want to be able to navigate to another page. So this is a pretty common UI architecture. So for navigation, you can actually use React navigation component. So it's an extensible and yet easy to use navigation solution. So let me show you a very quick demo. So I have built a very simple application containing 3 tabs: news, speakers, schedule. So on the first page, nothing fanciful. On the second page, which is the speakers, I have a button here. So if I tap on this button, it will navigate to the talks page. And notice that if I tap on the back button, it will return me back to this page. Okay? So it's a combination of tab pages plus navigation pages. So let me show you how it looks like. So I'm going to close this packager manager. And then I'm going to also see using navigation. And then I'm going to run this. Put this one side. And so let me just run through the slides first. So it basically contains 3 tabs. News, represented by news.js, my JavaScript file. Speakers, speakers.js. And this speakers is going to navigate to talks, which is represented by talk.js. And I have another tab called schedule, represented by schedule.js. Now, so in order to piece all the navigation together, I create a file called router.js. So this is how it's going to look like. So I create, first of all, what we call stack navigator. So I have the new stack. So my new stack only have 1 page. And I have my speakers stack. My speakers stack has got speakers as well as talks. And then I have a schedule, which only has got 1 page. And I put them together using what we call a tab navigator. A tab navigator has got the following. So these are the items, these are all the tab pages. So I have my new stack, speaker stack, schedule stack. And so the end result of this is something like what I have here. So I have my news, I have my speakers, I can swipe, schedule, go back. If I click on this view talks, I can navigate back as well. Okay, now, and if I go to view talks, I will see this page. Now, earlier on, I talked about this thing called live reload. Live reload basically means when I make changes to my page, it would automatically be refreshed on the device or emulator. There is one more term called hot reload. Sometimes when your app is deeply nested, so you navigate to a lot of pages, live reload will not be able to update your navigated pages automatically. So what you need to do is you need to make some changes, reload your application, and then you navigate back to the page again. So hot reload overcomes that limitation. So let me show you. So I'm using navigation, Android. Oh, no. So this is the talks application. So talk application. So I have my talk page. So my talk page corresponds to whatever I have here. So what I can do here is that I can go here and I can say that I want to, hang on. I have previously enabled that, so I'm going to disable and show it to you again. Okay, so let me just show it to you again, and then my talks. So, and I'm going to enable hot reload. Previously it was live reload, this time hot reload. So I'm going to do a hot reload. And so now when I go to here, look at this, and I'm going to change this to my talk page, my session page. And when I save this, it will automatically do a hot reload, and it will change automatically. Okay, so sure.
So when would you want to use live reloading then?
Live reloading is when it applies to the main page of your application. So for example, in your application, you only have one page. Then live reloading is really useful. But then when in a more complex application where you actually navigate into other different pages, then that's where hot reloading comes in.
So hot reloading would still work on a single page?
Yes, it will work on a single page as well as pages that you have navigated. Okay, so that's pretty cool. So that saves you a lot of time. So when I was developing this NDC application, I realized that, wow, I can really save a lot of time. So normally when you use Android Studio or you use Xcode, whenever you make changes, you have to deploy, and then you have to test it all over again. But using live reload and hot reload, things are really that simple. Okay. So that is hot reload. So, okay, and then finally, index.android.js, I just need to load from my router and just add in the tabs. Okay, one final thing that I want to show you, dynamic updates. So I mentioned about CodePush earlier on. So this is how CodePush works. So you are the developers. It looks cool, right? So after you have deployed your application to the App Store or Google Play, you want to make changes. What you need to do is you just need to modify your code on your site. The reason why I have a ninja here is because you can update your app without letting Apple or Google know. So this is pretty cool. So you write your app, you make your changes, and then you pass it on to CodePush, and then your application itself, either you can actually automate the checking of updates every half a day, every 2 days, or you could actually ask the user to press a button on the app to check for updates. If there are updates, download this over to this site, refresh the application, and then you have the latest version of your app. So these are the steps to use CodePush, but let me show you a demo. I think showing you a demo is more fun, right? I just realized that I did not plug in my power, so we are left with 11%, but never mind.
Question on CodePush.
Sure.
So does it update the app even if the user doesn't ask for it? Or does it ask?
The user will be prompted. The user will be prompted with a dialog. Yeah. Okay, so let me just close off this guy. Terminate. Wait, hang on. I think it's better to plug in my power because I think this machine will go to sleep when it's less than. Okay, but never mind. Let me try my luck. So, okay, and then let me just try to deploy this guy. Okay. So I'm going to deploy this application onto my emulator. And let's move this one side. And so this is my application, my dynamic app, and let's make some changes to that later on. Okay, let me just save some time here while I'm deploying my CodePush. Actually, I got quite a number of things to talk about, but I don't think I have enough time. But let me share something with you. If you're trying to build something fun, there's something called gifted chat. Have you heard of this thing called gifted chat? If you are trying to build a chat application, you need to build the UI, right? So your UI should look like this, where you can actually talk to somebody, and then you can receive a message from somebody. So when I was building this application, this NDC application, I actually built this application for a previous conference, DevTeach at Canada. So I incorporated this chat feature into the app. So this feature would allow fellow participants of the conference to actually talk to each other. So while you're sitting there, you can use my app to chat with each other and exchange opinions about this session or whatever. So but then I realized that developers don't like to talk to each other. When I deploy the app, I realized that nobody's using that functionality. So for this particular app, I did not include that. So, but this is something that's really, really cool. And you don't have to get your hands dirty on building the UI. Somebody has done that for you, gifted chat. If you go to Google, you search for React Native gifted chat. It is cross-platform. It works for iOS. It works for Android. And you have a very nice chat user interface. And you can view, display pictures of the people who are talking to each other. And then you combine this with Socket.io. You can actually have a back-end server. You can do sockets programming. So it's really, really cool. Anyway, OK, so my CodePush is done. So this is my application. So let's just imagine that this application has been deployed to Google Play. And I want to make some changes. So I go in, I make some changes, save this, and I go back to my application here. Assuming that I have already previously done all my setup with CodePush, I simply need to do this. Let me just show you the command. I have the command somewhere here. No. Yeah, there you go. So I just need to do this. CodePush, release React, my dynamic app, which is the name of my application, followed by the platform Android. Enter. And my code would now be pushed to CodePush. So it will do the processing, the packaging, upload this to the CodePush server. And what I have here on my application here is that I have a button to allow the user to check for updates. So I need power. I need power. Where is... This is really anticlimax. But don't worry, I have one more session after this where I'll be talking about iOS. It's almost the same stuff. So if you don't mind listening to my jokes again, you can always attend my session. But okay, I hope they did not kill my. But in any case, so when I click on the button, check for updates, it will first of all check with CodePush to see if there is a newer version of this app available. If no, nothing happens. But then if there's a newer version, it will prompt a dialog to ask the user, do you want to actually update your application? The user can say install, and then the application will be updated with a new UI. Okay, so Have I run out of time? Okay. So I think I can't show it to you. But if you want to see this, hang around. I'll show it to you. I'll prove to you that it works. Okay. Okay. So I think we have run out of time. I need to rush over to the other side. But if you have questions for me, please go ahead and I'll be around. Okay. Thank you very much.